AI ML in Anomaly Detection. In the complex and data-rich realm of detecting anomalies, machine learning ML serves as an invaluable and increasingly essential ally. By training algorithms to recognize typical user activity, network behavior, and system processes, you can significantly enhance the detection of truly unusual and potentially malicious activity beyond what traditional rule-based systems can achieve. Imagine feeding a machine learning system vast amounts of historical data about 1. User behaviors, typical login times, usual accessed resources, common file activity. 2. Network behavior, normal traffic volumes, common protocols, usual communication patterns between internal hosts. 3. System activity, standard process executions, resource utilization. As the machine learns these complex multi-dimensional patterns, it can then flag deviations in real time. For instance, if an employee who consistently logs in from New York suddenly attempts to log in from a different country, within minutes, an ML-powered system could flag that as highly suspicious, suggesting a compromised account or travel anomaly. We make use of the following machine learning techniques for anomaly detection. 1. Decision trees, for classifying normal versus abnormal. 2. Neural networks, for identifying complex patterns in large datasets. 3. Clustering algorithms, for grouping similar behaviors and spotting outliers. Machine learning can analyze intricate patterns and vast amounts of data much faster and often more accurately than manual methods. What's more, these systems can continue learning as new data comes in, continuously adapting to changing user behaviors, network configurations, and even new attack patterns, thereby improving accuracy over time. This means you're not just relying on static historical data. You're building a dynamic, self-improving model that helps you stay ahead of constantly evolving threats. Network security monitoring. Network security monitoring is a cornerstone of protecting any organization from cyber threats. Think of your network as a busy multi-lane highway where all your organization's digital traffic flows. Just as traffic controllers need to watch for erratic drivers or unexpected roadblocks, we must pay close attention to unusual behaviors, suspicious patterns, or unauthorized activities in our data flow. By continuously scrutinizing your network traffic, you empower yourself to identify vulnerabilities, ongoing attacks, or breaches before they can fully escalate and cause significant damage. Key indicators to monitor in network traffic include 1. Spikes in traffic, unusual surges in inbound or outbound data, which could indicate a DDoS attack, data exfiltration, or a large-scale malware infection. 2. Unusual port activity, communication attempts on non-standard ports or attempts to connect to services that shouldn't be publicly accessible. 3. Anomalous protocols, the use of unexpected or rare network protocols in your environment. 4. Communication with known bad IPs, connections to IP addresses or domains identified by threat intelligence as malicious. 5. Failed connection attempts, a high volume of failed connection attempts to internal systems, signaling a potential reconnaissance or brute force attack. Effective network monitoring provides crucial visibility into horizontal movement of attackers within your network, often revealing lateral spread or data staging activities. Network monitoring technologies. To achieve effective network security monitoring, several sophisticated tools and techniques come into play, each contributing a vital layer to your defense. Leveraging the right combination of these technologies is key to gaining comprehensive visibility. The following are the most widely used network monitoring technologies. 1. Security Information and Event Management (SIEM) systems. SIEMs are at the forefront. They are essential for aggregating log data from various network sources like firewalls, routers, switches, and intrusion detection prevention systems. More importantly, they provide real-time analysis and correlation of security alerts generated by these network hardware and applications. With a SIEM in place, you can correlate network events with endpoint and authentication logs to pinpoint complex anomalies that could indicate a breach, rather than just isolated alerts. Intrusion detection systems (IDs) and intrusion prevention systems (IPS). These act as your protective shield and alarm system directly on the network. IDS passively monitors network traffic to identify signs of malicious activities or policy violations. Think of it as a security guard who not only stands watch but also looks for suspicious behaviors. IPS goes a step further by actively blocking or preventing identified malicious traffic in real time. Both are crucial for detecting and responding to network-based attacks. 3. Network flow monitoring tools such as NetFlow IP Fix. These technologies collect metadata about network communications, who is talking to whom, for how long, how much data, without collecting the actual packet contents. This provides high-level visibility into network traffic patterns, helping detect anomalies like unauthorized connections or data exfiltration. 4. Packet capture PCAP tools. Tools like Wireshark capture raw network packets for deep-dive forensic analysis. While not for continuous monitoring, they are indispensable for detailed post-event investigation of suspicious network activity identified by CM or IDs. The right combination of these tools equips you to create a robust network security stance, allowing you to manage network-related incidents effectively and maintain a secure data flow. Endpoint security monitoring. While network monitoring watches the data highway, endpoint security monitoring focuses on the individual gates or devices where users interact with data: laptops, desktops, servers, mobile devices, and IoT devices. Monitoring endpoints is absolutely crucial for preventing insider threats and detecting malware that might have bypassed network defenses. Here are methods for endpoint monitoring. 1. Continuous monitoring of user activity. This involves tracking user behavior, file access patterns, process executions, and application usage over time to spot anomalies that deviate from the norm. For example, if a team member who usually accesses files related to marketing suddenly starts looking at highly sensitive financial data or installing unauthorized software, this could be a red flag for a compromised account or an insider threat. 2. System logs analysis. Collecting and analyzing logs generated by endpoint operating systems such as Windows event logs and Linux syslog applications and security software provides detailed activity records. 3. Process monitoring. Tracking every process executed on an endpoint, including its parent process, command line arguments, and network connections, is vital for detecting malicious execution. Your goal is to create a multi-layered defense system that not only reacts to threats, but also proactively anticipates them by understanding the behaviors occurring at the very edge of your network. Endpoint monitoring tools. Endpoint monitoring utilizes tools like EDR for real-time detection and response on devices, CM for data aggregation and correlation, HIDS for host-based activity, and TIPS for alert enrichment. This integrated approach, combined with keen observation, creates a robust defense against insider threats and malware. You've now gained a comprehensive understanding of security monitoring techniques, the art and science of watching over your digital environment. Continue honing skills through practice and community engagement to excel as a SOC analyst. See you on the next module.